Okay, in this video, we're going to look at solving trig equations. So we're going to start with solving linear trig equations. Okay, so we're going to solve for theta when theta is between 0 and 2 pi. So 0 and 360, but we're going to use radians. So we need to make sure that we're looking at these questions to see whether it's 2 pi or 360, so we know whether to give the answer in radians or degrees. First one we're going to look at. So sine theta equals 1. This is pretty straightforward. If you draw the sine graph, sine theta equals 1 at pi over 2. Okay, so look at the sine graph, pi over 2, sine theta equals 1 there. Okay, so the only answer is pi over 2 between 0 and 2 pi. All right, so something a little more difficult here that we might have to work around. So 2 sine theta minus 3 equals negative 1. So think of the sine theta like an x. Okay, kind of like this. So 2x minus 3 equals negative 1. First, you have to solve for the sine theta. So you have to solve for the x, add 3 to both sides. Then you get 2x equals 2, and divide by 2, and you get x equal to 1. Same thing over here. You can add 3 to both sides. Then you're going to divide by 2, and you're going to get sine theta equals 1. And the answer is the same as what we got above. Okay, so this question could be more complex looking like this. I got theta equal to 2, pi over 2. Okay, this example, root 2 cos theta equals negative 1. Well, again, you're going to divide both sides by root 2. And you got something like this. Okay, and cos theta equals negative 1 over root 2. So cos is negative on this in this quadrant over here, okay, the quadrant 2 and 3. Okay, so these two, so it's going to be, so if it was just cos theta equals 1 over root 2, the related acute angle, so theta r, for this one, would equal pi over 4. Okay, because it has to be in this quadrant and this quadrant, it's going to be pi minus pi over 4, pi plus pi over 4. So these are the two answers that we get. 3 pi over 4 and 5 pi over 4. Okay. Tan theta equals 2. What about this one? Okay, so you can pause the videos and try these. See if you get them and then check the answers. So tan theta equals 2. Well, we want to find theta r, so the related acute angle, okay, by doing tan inverse of 2. If that was tan theta equals negative 2, you'd still do a positive 2 because we want to find it in the first quadrant. Okay, when is tan theta positive? Well, it's in quadrant 1 or quadrant 3. Okay, so if you do this on your calculator, you're going to get 1.11 radians approximately. So that's going to be the first angle. The second angle is going to be pi plus that. Okay, so 1.11 and 1.11 plus pi, and that gives me our two angles. Okay, so those are some simple linear trig equations. Let's look at a few more here. Okay, what about this one here? So 2 cos 2 theta minus root 3 equals 0. Now we have a 2 theta in here, which we're not going to worry about until we get further down. So we're still going to just solve for cos 2 theta first. So bring the root 3 over, divide by 2. Okay, and if we just think of 2 theta as one angle, like an x, then cos is positive in these two quadrants, and it's cos of pi over 6 or 11 pi over 6 that gives me root 3 over 2 if you look at the special triangles. Okay, so 11 pi over 6 is the related acute angle. Now, because it's 2 theta, if you just look at the graph of cos 2 theta, there's 2 cycles between 0 and 2 pi. That's what the 2 means there. Okay, it's been horizontally stretched by 1/2. So one period is in 0 to pi instead of 0 to 2 pi, or there's 2 cycles between 0 and 2 pi. So because there's 2 cycles, it's going to go around twice. So we got pi over 6, 11 pi over 6, and then you're going to add 2 pi to both of those. Okay, so these are the answers for 2 theta. Once you've got that, now you have your 4 possible answers. Okay, and now when you divide them by 2, you're going to have answers that are between 0 and 2 pi. Okay, so 2 pi would be 24 pi over 12. 23 pi over 12 is just less than that. Okay, so when you have 2 theta there, you could have as many as 4 answers. Now, another way of looking at this is you could have used one of our identities. So 2 cos 2 theta minus root 3, you could have done this. Okay, taken the 2 out. Cos 2 theta is just 2 cos squared theta minus 1. Okay, simplified that. Now we have a quadratic. Okay, so we rearrange this, bring the 2 over, bring the root 3 over, divide by 4, and now we've got this. Now when we take this is like a difference of squares, so we're going to have actually 2 answers to this when we square root it. So square root, then you've got a plus or minus. Now you've got an answer in all 4 quadrants, and you can deal with the positive and the minus. Problem with doing this is it's hard to tell what the exact answer is, like in the previous one. So in this one here, we got exact values. This one here might be harder to see exact values, but it's doable. Okay, and similar situation here. Instead of 2 theta, what about x over 2? So cos of x over 2 is root 3 over 2. In this case, you're only going to have a half a cycle between 0 and 2 pi, because k is 1/2, or k is 2, right? So you're going to have a half a cycle, because that's like 1/2 x between 0 and 2 pi. But we can find more answers than what we need, and then we can eliminate the ones that are too big. Okay, so for this, we're going to have cos is positive in these 2 quadrants. So it's going to be pi over 6, 11 pi over 6. Okay, checking with the special triangles. So theta r equals pi over 6. Okay, so that's that one there. And because it's cos is positive in this quadrant, it's going to be pi minus pi over 6, which is 11 pi over 6. Now we multiply the answers all by 2 to get rid of that divided by 2. And when we do that, we get 2 pi over 6 and 22 pi over 6. Reduce that, and we get x is pi over 3 and 11 pi over 3. Now 11 pi over 3 is bigger than 2 pi. 2 pi would be 6 pi over 3. Okay, so this is too big. It's outside of our zone of 0 to 2 pi, so we don't include it. But we do have one answer. All right. What about this one here? So this example, well, we got sine 3x equals negative root 3 over 2. Same idea. You're now going to have 3 cycles between 0 and 2 pi. So you should possibly get 6 answers. Okay, it's negative, so we're going to find the related acute angle, which is pi over 3. Okay, so pi over 3, but sine is negative in quadrants 3 and 4, okay, wherever y is negative. So it's down here. So you're going to add pi over 3 to pi and subtract it from 2 pi, and we get our answers of 4 pi over 3 and 5 pi over 3. Well, we're going to have to add 2 pi to each one of those for the second cycle, and then another 2 pi for the third cycle that's between 0 and 2 pi. So we've actually got all of these solutions. Okay, so the first 2, then add 2 pi to both of those, then add another 2 pi, and now we have our 6 answers that you could get in 3 full rotations. Simplify those. Okay, so work these out. You can pause and check these answers. And then you divide everything by 3, and here are our solutions. Okay, so that is some examples for linear trig equations. Now here's some examples from the textbook. Okay, so we're going to look at these here. So first, on page 428. Okay, so 428, number 11. So page 428, number 11. I'm going to bring the book over here. And number 11, we can see here, zoom it in just a little bit. Okay, A city's daily high temperature in degrees Celsius can be modeled by the function T of D equals negative 28 cos 2 pi over 365D plus 10. Okay, so here is the model, where D is the day of the year and 1 equals January 1st. Okay, so it's all defined here for us. On days when the temperature is approximately 32 degrees Celsius or above, the air conditioners at a city hall are turned on. During what days of the year are the air conditioners running at City Hall? Okay, so you got to take this and look at when the temperatures are going to be 32 degrees or above. So we want to graph this. So we know that the amplitude is 28. It's a coast that starts from the bottom. Okay, so January is coldest, so it's going to start from the bottom. Shift it up 10. Okay, and we're going to use this to figure out the period of it. Okay, so let's go back to the question here. All right, so the period, the way you calculate the period is always 2 pi over the k value. K value is 2 pi over 365. And when you simplify this, you're just going to get 365, which makes sense, 365 days of the year. Okay, so that's the period, which gives us this k value. Now, if we were to graph this, the one full cycle in 365 days, the axis was at 10 right there, and we want to know when is the temperature going to be above 32 degrees. So we want to solve this equation for this and this. And once we've solved that, we know that the days in between here are going to give us our days when the air conditioner is going to be on, because the temperature is going to be above 32 degrees there. Okay, so we want to solve this inequation to when T of D is greater than or equal to 32. Okay, so we're going to rearrange this, bring the 10 over, divide by negative 28. When we do that, divide by negative, remember we got to flip the inequality. Okay, and then we eventually get down to this. So to solve this, we need to solve this first, the equation. So cos of theta equals negative 11 over 14. We're just replacing theta here with the 2 pi over 365 times d, and then we'll throw that in later. Okay, so we're going to solve for this first. So all we're going to do is go cos inverse of 11 over 14. Okay, remember if we use the positive of this, we can find the related acute angle. Cos is negative in these two quadrants, so once we find theta r, then we can just subtract it from pi and add it to pi. Okay, so here's theta r. Now, we're going to subtract it from pi and add it to pi to get these two angles here. Once we've got those, so we've just used our calculator to get this, we've added these up. Now we can replace theta with 2 pi. Okay, so we replace theta with 2 pi over 365. So times d. Now we can bring this over, divide this out. So divide this by 2 pi over 365 and this by 2 pi over 365. And we end up with these numbers here. So at day 144 and day 222, so between there, we're going to throw on the air conditioners. And you can work out which days those are depending on the year and so the month and day if you want to. Okay. Now, the next question we're going to look at is question 12 on the same page. Okay, so question 12 on page 428. Okay, so number 12. Let's take a look at it here. Okay, so 12. All right. The height in meters of a nail in a water wheel above the surface of the water as a function of time can be modeled by the function this. Okay, where t is the time in seconds. During what periods of time is the nail below the water in the first 24 seconds the wheel is rotating? Okay, so during the first 24 seconds. So let's take this function and look at it. So during what period of time is the nail below the water level? Okay, so below the water level, which is at 0. Okay, so let's take a look. Well, here is our function, and we're going to graph it. Okay, so the period equals 2 pi over that value, pi over 4. Okay, and so the period equals 8. Okay, so 8 goes into 24 3 times. So we're going to look at this now. So the axis is at 2.5. Okay, we've graphed this here, so we graph it and then shift it forward by 1, or I can just shift the axis back by 1. Okay, and put these numbers in. Now, here's the graph. We want to know when it's below the water level, so when it's below 0. Okay, so once you've got this graphed, we want to look for this point and anywhere in between there. And it's going to happen probably 3 times because we got period is 8. Okay, now here's how we go about it. Same sort of way. So you've got h of t is less than or equal to 0. So we want to solve this, and you bring this over, and now you've got sine of pi over 4 times t minus 1 is when is it greater than or equal to 2.5 over 4. Okay, so the 2.5 over 4. You're going to call this theta, and then solve for theta r. Okay, so theta r equals sine inverse of 2.5 over 4. Now keep in mind, there's more cycles in here. You got to draw it up to 24 seconds for this question, and figure out probably 3 intervals of time. Okay, so I'm going to leave this one at that so that you can finish it, but this is a start for that question. And that's it for linear trig equations.